Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 8 today, looking at Section 8.4, Calculating Confidence Intervals for Proportions. So the idea behind how we do this is that proportion data follow the binomial distribution, which, remember, can be approximated by the normal distribution under the conditions that n times p and n times 1 minus p are both greater than or equal to 5. Remember that n is the sample size and p is the probability of a success in the population. So the confidence interval for the proportion is an interval estimate around a sample proportion that provides us with a range where the true population proportion lies. So the way that we calculate that confidence interval, we start with the sample proportion, which is called p bar, and that's calculated using x divided by n, where x is the number of observations of interest in the sample, otherwise known as successes, divided by n, which is the sample size. And then this is called the standard error of the proportion. I think we've looked at that before, although I'm not completely sure. Maybe not. That's the square root of p times 1 minus p divided by n. All right, sorry, my animations here are a little funky. Since the population proportion p is unknown, we're going to estimate it using the sample proportion p bar. So that's going to give us an approximate standard error of the proportion. And the notation we'll use for that is sigma sub p hat. Remember, we had something similar in the last section. We had an approximate standard error of the mean. And the notation we used for that was sigma sub x bar hat. So this is pretty much the same formula that we were just looking at on the previous slide, except again, since we don't know p, we're going to approximate it using p bar. So the approximate standard error of the proportion is the square root of p bar times 1 minus p bar divided by n. All right, so just like with other confidence intervals we've looked at, our confidence interval is going to have an upper confidence limit and a lower confidence limit. In the center of that interval, we're going to have p bar, our sample proportion, and then the margin of error, which we will add and subtract in order to get the lower and upper limits, are going to be found using z sub alpha over 2 times the approximate standard error of the proportion. So this is similar really to what we've done in both of the last two sections. In the last section, we had to use the student's t distribution instead of z. For a confidence interval for a proportion, we do use z because, again, we're using the approximation using the normal distribution. So z stands for, comes from the normal distribution. All right. So again, that quantity z sub alpha over 2 times the approximate standard error of the proportion is called the margin of error. So a shorter way to express these upper and lower confidence limits is to just say p bar plus or minus the margin of error. And that represents the width of the confidence interval between the sample proportion and either its upper or lower limit. All right, so here's an example. From a random sample of US citizens, 22 out of 100 people are found to have blue eyes. So let's calculate a 98% confidence interval for the population proportion of blue eyes for US citizens. So first we'll calculate the sample proportion and approximate, sorry, this is, okay. Approximate the, what is that supposed to say? All right, well, it's the standard, approximate the standard error of the proportion, okay? Sorry about that. So P bar is x over n. 22 blue-eyed people out of 100 in the sample gives us a sample proportion of 0.22. And then the approximate standard error of the proportion would be the square root of p bar times 1 minus p bar divided by n. This is another one of those things that you should definitely try on your calculator. Make sure that you can get that to come out to 0.041. Okay, so I managed to fix up this slide so you can actually read it now. All right. So what we just did is we calculated the sample proportion and the approximate standard error of the proportion. The next step is to find the critical values, Z sub alpha over 2, for a 98% confidence interval. And I believe from section 8.2 that you have a chart that lists the critical values for various confidence levels. So you can either look in that chart to get that the critical value for a 98% confidence interval is 2.33. The other way you can do it is to use table A2 and look for the Z-score that has an area 0.01 to its left. And for that, you'll get negative 2.33, and then you just have to disregard the negative. Critical values of Z are always positive. All right, so now we have all the ingredients to calculate our interval endpoints. So the upper confidence limit is P bar plus Z sub alpha over 2 times the approximate standard error of the proportion. So that's 0.22 plus 2.33 times 0.041. And that comes out to 0.316. The lower confidence limit, we take P bar and subtract that same quantity, the margin of error, and that comes out to 0.124. So what that means is that based on our sample proportion of 0.22, we are 98% confident that the population proportion of people with blue eyes is between 0.124 and 0.316. So somewhere between 12.4% and 31.6% of the population probably has blue eyes. And that's the idea behind finding finding a confidence interval for a proportion. We'll see you next time.